Hi, I'm Patrick Daleiden. I'm a doctoral student in computer science, and I'm trying to study how to simplify high-performance computing for scientists. The specific problem I'm interested in are the kind of problems you can't solve on your single computer, the kind of problems that require clusters of computers and supercomputers to solve computationally intensive problems. These kind of problems, the problem with programming for it is that the knowledge level required for an engineer to do this kind of software is that at such an advanced level, it's almost impossible for an applied scientist to have the knowledge in the other field that he's doing. So what we're looking at with a supercomputer is not just a faster computer. It runs at about the same speed as a computer on your desktop. The thing that makes a supercomputer is that it's a cluster of thousands, tens of thousands, even millions of nodes. And these computers are so difficult to program because getting these things to work in parallel is a completely different problem than the computational algorithm. So what I'm looking at is how to make this easier. If you look at the example of the gobbledygook code on the left, you see the kind of instruction that's needed to offload and distribute a problem across these nodes of computers for even a very simple algorithm. When scientists are working with complex problems, the problems multiply exponentially. So what I'm trying to do is move this into something that's more intuitive and natural and abstracted to be able to still give the computer the instructions that are necessary in order to do this offload in high-performance environment. So the way I'm doing this research is the first thing I did was a deep dive into an applied scientific field. So I spent 2 weeks this summer out at the Institute for Advanced Study with 150 theoretical physicists working on all the different computational models they have in computational astrophysics. And what I learned from this is not only the nature of the types of computational problems that they're trying to solve, but that these are already very gifted programmers. They don't have a lack of programming knowledge, but they're still struggling with some of the fundamental concepts of how to do parallelism. So I'm specifically studying how to do this. And the way I'm doing this is I'm designing a system and I'm testing it using human factors research and randomized control trials and actually measuring their performance and comparing the different types of intuitiveness that you can resolve from this. My master's thesis, I developed some automated technology to score called token accuracy maps that allow us to compare and hone in on the specific areas of problems that people are having. And so what I'm hoping to do with this is design and build the compiler tools and that to be able to do something in a more abstracted, simple level that allows people to do the kind of scientific discovery that they do and focus on their applied area instead of having to fight with this kind of low-level arcane code that exists currently in the system. The goal of all this, of course, is to advance the pace of scientific discovery in every field by giving them the power of the computer. Thank you.